In this video, we will be talking about the Baravelle spiral and how it connects to geometric series of different shapes. So as we can see, we have a couple different Baravelle spirals here. We have a blue one, a red, a green, and a yellow. And the neat thing about a Baravelle spiral is, for any regular polygon, you can make this shape. You can do it with triangles, squares, hexagons, pentagons, septagons, octagons, whatever you would like, you can make this shape. Let's explore how to do that. First, we start off with a square, and then with that we find its midpoints, and we connect these midpoints. And with this another square that we've made, we find more midpoints and keep connecting them until we go down to about here, is about as small as we can get. So to make a Baravelle spiral, we must first start off with one triangle, and from there we're going to go down a step to the next smallest triangles. So there's 1, 2, 3, 4 triangles that are the next smallest. We'll pick one of them. We could pick this one over here and have the spiral go down this way, but let's just keep it going clockwise. So we will now pick this triangle and the next triangle, and so on and so forth. So we'll keep going down until we go down to the smallest triangle, and then we will select all of them, and we can see, oh come on, how they make a spiral. And so if we make it all nice and pretty, and let's say make them red, we now have a red spiral. But as we saw in the beginning, there's more than one spiral going on here. So if we look at this, we could go down these triangles and create another spiral. We could start off with here and go down and make another spiral. So really there are 4 spirals. And the cool thing about that is we notice that each one of these triangles, this triangle, this triangle, this triangle, this triangle, the same shape, this triangle, this triangle, this triangle, same shape and same area, as well as this triangle, this triangle, this triangle, this triangle. So really, each step of this triangle you have the same size, and then if you go down a step you have the same size as well. And so each one of these tiers going down on this spiral has each one of these colors being the same size. So going down the whole entire spiral, we have the red spiral being the same area as the green, as the yellow, and as the blue. Now, we mentioned geometric series at the beginning, so let's talk about what a geometric series is. A geometric series can be written out in this form. You have a summation starting with k equals 0 up to infinity of some term here. And how we discover that term is based on what shape we have. So it's always going to be a constant a times r to the k, where k is going to be changing from 0 to infinity. So we start off with ar to the 0, which is just a, because any number to the 0th exponent is just 1. And then after that we go on to 1, because we just add 1 to our index, so we have ar to the 1, or ar to the 2, 3, 4, so this is our series. It starts off with our first term and goes all the way up till infinity, so it's an infinite sequence. So this is called a geometric sequence. Now how do we arrive at what the geometric series is for this? Well, we start off with our first term being a, so we want to find out what the area of our first shape is. So we look at this triangle, and we notice that there are 8 other similar triangles that have the exact same area. So 1, 2, 3, 4, 5, 6, 7, 8. So each one of these triangles is the same. So we can conclude that if you start off with a square, if we just hide these objects, if you start off with a square and find its midpoints, when you connect those midpoints, when we connect the midpoints, that each one of these triangles that is connected from the midpoints will be 1/8 of the original square. So from there, we're going to hide these. We start off, we have, so this is 1/8 of our big triangle. So now we move on to these midpoints and connect our lines. And we notice that we have 1, 2, 3, 4, and then if we connect these, oh no, come on. If we connect these, oh, that's bad. If we connect these, then we have this same idea that 1, 2, 3, 4, 5, 6, 7, 8. Each one of these triangles is 1/8 of this size. But what is the area of this inner square? Well, it's simply 1/2, because we have 1. If we go back and we remember that this is 1/8, this is 1/8, this is 1/8, this is 1/8. If we have 1/8 and we have 4 of them, then that equals 1/2. So if we have these 4 square triangles being 1/2, then this inner square must be the other 1/2. So then if each one of these is 1/8 of that 1/2, that is how we arrive at what our ratios are. Because to go from this triangle right here down to this triangle, it's simply 1/2 of this eighth. So that's how we get our terms. We look at what the area is, and then we compare it to what's left and what size, what area are we taking of that. So our geometric series is going to be the summation from k to infinity of 1/8 times 1/2 to the k. And that is how we get the summation of this. So if we want to find the area of our red spiral going down, we just simply take the summation of however many triangles we have, and we start off with k being 0 all the way up to the number of triangles we have of 1/8 times the quantity 1/2 to the k. So to find out the area of this spiral, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 triangles. So when we do our summation, instead of being infinity up here, we would have 9, because we are counting up 9 different triangles. Now let's look at our hexagon. So this is a hexagon spiral. It's the same thing as a square spiral, only our shape is going to be a hexagon. So you can see that each one of these are triangles, and we make our spiral. So how do we make this? Well, of course, we have our hexagon. We found our midpoints, and we're just going to connect these midpoints with lines, find more midpoints, and keep going. And as before, you pick a triangle, you shade it in, you go to the next triangle in the spiral and shade it in, and so on and so forth. And the thing about this one that's different than the square is going to be the number of spirals, because we have this spiral starting out, and then we're going to have this spiral starting out. We're just going to draw 3 of them. Then we're going to have this spiral, and as you can see, each one of these spirals starts off at a side. So in order to start a spiral, you need a side to start from. And so the number of sides we have are 6. Therefore, the number of spirals we have is also going to be 6. And this comes into play because when we do the geometric series of these different shapes, we're going to have to find out how big our sides are and such. So we have 4, and you can see we have 2 more after this. So if we just connect these real fast, then we can see that we have 6 spirals that are going down. So we have 6 different spirals, and it'll continue on until we get down to as small as we can. It goes on for infinite. We can have an infinite number of shapes, or you could just say, okay, I want to know how big this area is, and we'll do that through the geometric sequence. So why don't we start finding out some of the areas that we need. So right here we have the big hexagon, and each one of these has been colored in. And we did a bunch of reflections and rotations to fill this whole thing in with the same shape. So what we're going to do is we're going to count out the total number of triangles of this size that there are in here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we have a total of 24. So that means the size of this triangle right here is 1/24 of the total. And so now we have to find out how much is remaining on the inside. And we notice that there's 1, 2, 3, 4, 5, 6, and we know there's 24 total, so therefore 18/24 or 3/4 is the amount of area that's on this smaller hexagon. So these two numbers, 1/24 and 3/4, are going to come into play. Nope. So if we look at our geometric series again, we're going to notice that we have 1/8 is our, or 1/24, I'm sorry, 1/24 is our starting number, because at the beginning of our spiral, if we want to find out how much this is, we take the summation of our first term, and we go from 0 to 1, and if we put in 0, we'll just get this, and so that's what we want. We want A, since A is 1/24, as we saw, each one of these is 1/24, and R goes from 0, so it just turns into 1, so we're left this one shape being 1/24. And now we want to find out what the size of these areas are. Well, we know that they're going to be 1/24 of this inside hexagon. And we discovered that our inside hexagon is 3/4 the size of our larger hexagon. If you remember that this inside hexagon was 18/24 or 3/4 the size of our larger hexagon. So we know that this shape is going to be 1/24 of 3/4. So that's where our R value comes in. And as soon as we go down a stage, it will be 1/24 of the 3/4 of the 3/4, and so that's where we get the squared term. So if we, where are you? Here you are. If we look at our two ratios, we have 3/4 and 1/24, and that comes from the area of the shape that we are adding to and how big of the total area of the shape that we are compared to the larger object. So A, this is 1/24 of the big hexagon being 1, and once we move down and we connect all these midpoints, we'll have another shape that is still using the same ratios. Where this shape, this one right here, is 1/24 of this smaller hexagon, and this smaller hexagon is 3/4 of our larger hexagon, so we have to multiply them together to get our bigger shape. And if we go down one more row, or one more layer, as some people call it, this is 1/24 of this hexagon, and this hexagon is going to be 3/4 of our bigger hexagon. So that's where we get 3/4 of our bigger hexagon, and that is 3/4 of our largest hexagon, so it's 3